students, how are you? সবাই কেমন আছো? আজকে আমরা lecture number 3 করব. Already two lectures are covered in lecture 1 and 2. In these lectures we already cover from the supplementary problem of 1.31 to 1.42 of the chapter 1 from the books Vector Analysis by the M.R.Spiegel book. So in this lecture we want to continue of the problem from 1.43 to 1.48, and if you are not see the previous lecture, you get the link in the description box, and so please see these videos. Okay, so in this question what is say that suppose a and b and c are non-coplanar vector, determine whether the following vector are linearly dependent or independent. If these vector are linearly dependent or independent, if this dependent, the coefficient determinant will be 0, and if they are linearly independent, then the coefficient of their coefficient must not be 0. So the coefficient of first vector is 2, second is -3, third is 1, then this is 3, this is -5, this is 2, and then 4, -5, 1, and you get the just determine this value. This is 2. I want to simplify this. I subtract this from that, so this is 2 minus 3 1, 3 minus 5 2, and 2 4 minus 2, that is 2, minus 5 minus 3, that is -2, 1 minus 1 0. And now I want to expand this determinant with respect to this column, that is 1 into -6 minus 10, minus 2 into -4 minus plus 6. Okay, so this is 4, and this is 2 minus 2 minus 4, this is 0. Since this is 0, so we can say this is the linearly dependent, so they are linearly dependent, dependent. Now if you want to find out the how they are related or how they are dependent, then you can take r1 vector is nothing but x r2 vector plus y r3 vector, and put the value r1 r2 r3 and compare the coefficient a1 a2 a3. This is the 2a1 2a minus 3b plus c is nothing but x into 3a minus 5b plus 2c vector, this is vector, plus y into 4a minus 5b plus c. Okay, so the coefficient of a is 2 and the coefficient of a is 3x plus 4y, then coefficient of b minus 3 is equal to minus 5x minus 5y, and then c is 1 equals to 2x plus y. Okay, so you can solve in taking any two equation. I take these two equation and multiply by this 4, this is 4 8x plus 4y, and use this equation in the here you get 2 3x plus 4y and minus these two, you get this is 2 and this is 5x, right? So the value of x is 2 by 5. Put this value in anywhere, I use in this, so y 1 minus 2x, that is 1 minus 2 into 2 by 5, that is 1 by 5. So the value of y is 1 by 5 and the value of x is 2 by 5. So we can say that r1 is nothing but 2 by 5 r2 vector plus 1 by 5 r3 vector. In this relation they are related, r1 r2 r3, and they are linearly dependent. Okay, next question 1.44 says, if O is any point within the triangle ABC, PQ are the midpoint of this AB, BC and CA respectively, then prove this. Okay, so this is a vector This is a triangle A B C. Okay, the midpoint of AB is P, midpoint of BC is Q, and midpoint of CA is R. Now we need to prove this OA vector plus OB vector plus OC vector. Okay, OA plus OB plus OC equals to, you can say OA. O is any point in this. This is OA vector, this is OB vector, this is OC vector. So OA vector can be written as OA vector can be written as I want to change the color. OA vector can be written as OR plus OR vector plus RA vector. Clear? Then OB can be written as similarly OP vector plus PB vector. OP vector plus PB vector. Then OC can be written as OQ vector plus QC vector. OQ vector plus QC vector. Okay, and this is OR plus OP plus OQ plus RA plus PB plus QC. See RA, you can say RA is the half of CA. So this OR plus OP plus OQ is okay, no problem, and this can be written as half CA. This is the half AB, so half as a common. This is CA, this is AB, and this is BC. Since the CA AB BC is a close, so this equals to 0. So we got OR plus OP plus OQ, hence proved. If this origin, this is the origin, if this is origin taken as here, this process will be same. So this is A. So in case of B, if origin is outside the triangle, the result will be same. So result, yes, result will be same if we take origin outside the triangle outside নিলেও result same হবে. Okay, next question says this in this figure the paragraph ABCD, the P and Q midpoint and side BCD respectively prove that AP and AC trisect at this point. Okay, I want to take A as the origin. This is origin 0, origin, that means the coordinate of A is 0, and take the position vector of B is V vector and position vector of D is D vector. If this is D vector and this is A vector, then the position of C vector must be B vector plus D vector. If this is B plus D, so take A is origin. A is origin. B, position vector of B, position vector of B is B vector. Position vector of D is D vector. So position vector of C is B plus D. Okay, then position vector of P. What is the position vector of P? P is the midpoint of B and C. So B vector plus C means B plus D by 2. That is nothing but B vector plus D vector by 2. Similarly, the position vector of Q is nothing but D plus B plus D by 2. This is nothing but B by 2 plus D. We got all the position vector. Now I take as the the point where the db is divided by 2 is to 1. Take this is a 2, sorry, this is a 2, this portion take as the 2, this is portion 2 and this portion 1. So at point f1 where b divided 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 by 2 is to 1 ratio. Okay, if these two are divided into 2 is to 1 ratio, then coordinate of f1 বা position vector or f1 position vector of f1 is, this is 2 is to 1, so we can say the position vector is 1 into d, this is 1 into d plus 2 into b by 1 plus 2, that is 2b plus d by 3. Now if I want to take this portion is 2 and this portion is 1, we know the coordinate of a and coordinate of p. So at point f2 where ap divided by 2 is to 1 ratio, so we can see position vector of f2, position vector of f2 will be 0 into 1, 1 into 0 plus 2 into position of p which is b plus d by 2 by 1 plus 2. This is nothing but 2 into b and 2 into d by b, that is d vector by 3. You can see these two are same, so you can say show f1 and f2 are same point, that is called f. So f divided this as 2 is to 1. Similarly you can prove you can prove e can divide db in ratio 2 is to 1. Since this is 2 is to 1 and again this is 2 and this is 1, so we can say this e and f is trisect the diagonal bd. Okay, hence this is the proved. Next question. Prove that the line joining of midpoint of two sides of a triangle parallel to the third and one has the half of its magnitude. That's mean if this is a triangle, this is a triangle A, B and C, this is a triangle ABC, and the midpoint of two sides, this is the midpoint of that and this is the midpoint of, this is D and this is E, this is the half and parallel to the BC. That's mean for this triangle we can say AB plus BC plus CA, this is must be 0, and we can say AD plus DE, AD plus DE plus D plus EA must be also 0, and you can say AD is nothing but half of AB, this is half of AB, D here, and EA is nothing but half of CA, this is here. So half AB plus CA plus DE equals to 0. So AB plus CA, from here you get AB plus CA is nothing but minus of BC. So this is minus of half BC. So this is plus DA DE equals to 0. So you can see DE is nothing but half of BC. Okay, so in this they are parallel, so DE parallel to BC, and you can say in the magnitude DE is nothing but half of BC. So in magnitude this is half and this is parallel. Okay, hence this is proved. Next, prove that the median of a triangle meet a common point which is a point of trisection of this median. Okay, take this is a triangle, this is A, B and C. Draw the medians AD, BE, this is E, and CF, this is CF. Okay, take position vector of A is A vector, position vector of B is B vector, position vector of C is C vector. Okay, then the position vector of D, position vector of D, what will be the position vector of D? D is the midpoint of B and C, so this will be B plus C by 2. Position vector of E, this is the midpoint of A and C, this is C plus A by 2. Position vector of F, this is between A and B, this is A plus B by 2. We got all the position vector of this. Now I take a point, the point G1, where AD divided by 2:1. Take a point G1 in the within the AD where this is in the ratio 2:1. So the coordinate of G1 is nothing but 2:1. Along this side this is 2 and this is 1. So 2 is multiplied at the coordinate of D. D is B plus C by 2, plus 1 is multiplied with the position vector of A, and 2 plus 1. This is nothing but A vector plus B vector plus C vector by 3. Similarly, the point G2 where BE divided by 2:1. G is what BD is here 2:1, that is G2 is 2:2 VE, so 2 and E, so 2 is multiplied with the coordinate position vector of E. E is the C plus A by 2, plus 1 is multiplied with B by 2 plus 1, which is nothing but A plus B plus C by 3. Similarly for G3 is nothing but the in the FC, so this is 2 into F is A plus B by 2 plus C by 3, so this is A plus B plus C by 3. So you can see this G1, G2 and G3 are the same. So G1, G2 and G3 are the same point, Z. Hence the proved they are intersect a common point and they divided into trisect, that means 2:1 in the 2:1 ratio. Okay, this is the solution. Next one is the proof that the angle bisector of a triangle meet a common point. Angle bisector meet a common point. This is a triangle ABC. The angle bisector of A is D, bisector is E, and this sector is F. This is the F. You can see this is the angle bisector, so this must be equal. Hence this is the midpoint of BC. Similarly, this is the midpoint of AC, and this is the midpoint of AB. And the similar process in the previous in this similar process, you can say this g1 g2 g3 are same, and you get the answer or the solve this problem. Okay, this is after this you get the take the coordinate of a, b and c, just like in the previous question. After take this a, b, c and follow this step, you get the similar answer like that. Okay, thank you for listening. This is all about me, and this is my contact details. For any query regarding physics, you can contact with me by WhatsApp or the Telegram channel. And please subscribe this channel if you are new in this channel, and press the bell icon for getting the notification of upcoming video regarding that, and share this video to your friends to helping each other and like this session. Thank you. We will meet soon in the next video. Thank you.